practiced last week with us, you already practiced how to solve for general solutions for these differential equations. And then we're going to use the initial condition, right? This information will help us find the particular solution, what you're going to type in into Delta Math. Okay? So let's first copy down, and you'll notice this problem is for the whole page. All right, so just get ready for... I'm not. Get ready for the whole page. All right. So I'm going to copy it down. Yeah? I know, right? And if you guys remember from last week, what am I trying to do in the first step? Get the y's together and then the x's together. So I'm going to move the 2 minus y. This 2 minus y, I'm going to move to the denominator over here. And you see the dx. The dx, I'm going to move out of the denominator to the right side. Okay? So I'm going to write dy over 2 minus y equals 2 times the cosine of x dx. All right? So that's not new. What is new is the fact that on the left side now, where do you notice that y is? In the denominator. So I'm just going to isolate the left side right now. And let me back up. I don't want to say isolate. That means something in math. I'm going to just focus on the left side. Okay? Because ultimately, I want to do, I'm going to go over here. I want to do the integral of dy over 2 minus y. Right? That's what I need to do. Right? So if I rewrite that 2 minus y, I would rewrite that as 2 minus y to the negative first power dy. Okay? Now, it's been a long time since we've done this, but this is an instance where I would want you to use substitution. Yes. That's what we're going to do right now. Okay. So what am I going to use as u? 2 minus y. And then don't forget, you always do du after you choose a u. What's the derivative of 2? Nothing. What's the derivative of negative y? Negative 1 dy. Okay? I know it's been a while since we've done this. So now watch what I do when I substitute it over there, right? Because ultimately, this is going to be u to the negative first power. All right, but, right, dy, right here, dy. If I look here, du is equal to the opposite of dy. Do I want the opposite of dy? No, I want dy. So when I write du here, what am I going to put in front of the integral symbol? The negative. I know, and this is not even new stuff. This is like first semester stuff. That's not true. It's this semester, but it's, a while ago. Okay. Now, at this point, we can find the antiderivative of u to the negative first power. Do you remember this one? This is a special one. The natural log of the absolute value of u. Don't forget to bring that negative. That's a special case. You should remember this. I told you guys to add 1 to this power. What happens when you add 1 to negative 1? You get 0. You can't have something to the 0 power here. So that should be like something's going on. It's the natural log of the absolute value of that u. So now we can replace the u with 2 minus y. All right, that is our u, and that is the antiderivative of the left side. So all that work we just did, all right, I'm going to write that here. I'm going to pause for a second. I know that was a lot, but how are we doing on the left side?
That's just one side.
That's just one side.
So rendering, is this going to get harder from here, right?
I think this one and the next one are as hard as it gets. I picked really difficult ones. Oh, and Calc 2, Calc 3, linear algebra. There's actually a whole course called Differential Equations. Okay. Oh, yeah. Let's do the right side. Let's do the right side. You're going to be fine. So I'm going to do the antiderivative notice what I did with the 2. You guys see what I did with the 2? Because if it's a constant, you don't have to do this, but I always put the constants up front. All right? Do you know the antiderivative of cosine? Is it negative sine? Isn't it just sine? Right? So if I take the derivative of sine, that's just cosine. Right? So this is going to be 2 times the sine of x plus c. I'm waiting. Yes, sir. Going backwards from cosine is sine. The derivative of sine is actually positive cosine, so you don't need any negatives on the right side.
Oh, wait, on the x is the only one.
I only do the plus c on x. Very good. That's from last week. Good job, Georgie. Everyone okay? We've kind of hit a checkpoint here where I've taken the antiderivative of both sides. Now what do I need to do? Solve. Thanks for that. Solve for y. If you wanted to, somebody said c. You can if you want at this point. I'll let you use the initial condition, right, this x and y, to plug in where you see x and y. Feel free, and then you can find c. I do not. I think I like to keep the way I've been teaching you the same. So I'm going to find the general solution first, and then once I have the general solution, then I'm going to find c. And then I'm going to write down the particular solution. It doesn't matter though, Jimena. If you wanted to find c right at this point, that's fine. But then you'd have to do my work I'm about to do right now. Okay. Everybody good? Okay. Now, do you see the negative that is in front of the natural log? I'm going to deal with that. Also, notice, what is this y value equal to? A positive one. So you see the absolute value symbols? I can take those off because when we have a positive value in that initial condition, you don't need them anymore. So I'm going to move that negative to the other side. So I'm going to write the opposite of 2 times the sine of x. Now, do I need to write minus c? No, I'm going to keep that as plus c. So even though algebraically you guys would think to distribute to both of them, you only need to worry about the thing that's not c. Everyone still with me? Okay, nice. Now, how do we, I don't know if this is why I chose this problem. This step right here is why I chose this as an example, right? Because in order to deal with this y, I need to do something that is, I like to say, swoop, but mathematically it's called change from a logarithmic equation to an exponential equation. Do you know what the base of this log is?
10.
No.
1.
It's e. It's e, right? There's a little tiny e right there. So this is what we do. We do e raised to all of this equals 2 minus y. I'm going to do that again. E raised to all of this equals 2 minus y. It's not. It's just called math. Yes, I like to go. Exactly. Now, what the weirdest thing that I have dealt with in terms of teaching this is students think these are different things. Have I changed anything? No, right? All I've done is I've changed what it looks like, but it's exactly the same. One is called a logarithmic equation. One is called an exponential equation, but it's the same thing. Right. Okay. Now, do you see this 2 here? What can I do with that 2? Move it over with subtraction. So I have e raised to, notice where is that letter c? It's in the exponent. Keep it there. I'm almost there. Do I want the opposite of y? No, I want y. So now watch what happens. Both of these terms need to become the opposite. So I'm going to throw a negative in front of that e. Notice, did I touch anything in the power? No, I didn't touch anything in the power. But you see how I have minus 2? That's going to become plus 2. So this, what I just found, is called the general solution. Okay? This is the general solution. All right? We still need to find the particular solution. So now I'm going to use the initial condition, which I think said, was it pi over 6? Equals 1. I'm going to use this from the problem to plug into my x and y to solve for c. And once I find C, I'm literally just going to copy this again. Got her. Copy this again, but write whatever my C is. Okay? All right, here we go. The opposite of E raised to negative 2 times the sine of, so what is my X value? 5 or 6. Yay, David. Thanks. They should be, are they underneath? Oh, did I already put it away? Put it away, David, I'm sorry. You only need one. There's 2 there, but you only need 1. Equals, what's my Y value? Positive 1. Okay, ready? Remember, there's something that's confusing. Raise your hand and ask. Move the 2 over with subtraction. What's 1 minus 2? Negative 1. I left a little space up here. Does anyone remember the sine of pi over 6? That 30 degrees is the same as pi over 6. What's...
Square root of 2.
No.
1/3.
That would be the cosine of pi over 6. Somebody said it. It's 1/2! Oh my gosh. Are they going to ask that on the AP exam? You betcha. All right, so the opposite of E. Okay. Half of 2 gives me 1. Now, do you see how there are negatives in front of the E and in front of the 1 on the other side? So they can cross out. So now I have E to the negative 1 plus C power equals positive 1. And then, this is my favorite part. At this point, I need you to know that E raised to some power that gives me 1. What does this some power have to be equal to? 0. 6. So this right here should be equal to 0. So C equals 1. Wait for it. All right. Remember this right here was called our general solution. So I'm going to copy it down. But where it says C, I'm going to put 1. So Y equals the opposite of E. And I did change the sides, but it shouldn't matter. Notice how I wrote like Y equals, but you can keep the Y on the other side if you care. Okay, don't give up because we do have another one to do. And the next one's actually more challenging than this one. All right, that was awesome. Man, that was a lot of time too. How long was that? That was 13 minutes for one. And you got to do 10. Sick. Say one more time. It is literally what I do for a living. I am living and doing it. My kids are what? They're lucky? Okay. I doubt it. All right. Ready for the next one? They're going to be what? Young Sheldon. Or was that what I was going for? Okay. Number 2. Flip it over. Number 2. Can you wait till I'm done? Because I want you to see it. All right, here we go. Number 2. All right, David, you're here for the whole thing. Okay. First step is the same as we've done for all of these. Get this stuff that says y with the y's, x's with the x's. So I'm going to put dy over 1 minus y squared. I've had some students in the past ask, could you bring the 4 with it? I was like, yeah, that's fine. But there's no reason to bring that 4 because is that 4 actually need to be with the y? No, right? The 4 is not inside the parentheses, so I can leave that 4 over there. Yes, go ahead. I just moved it over with division. Now I'm going to move the dx over. Guess I should put that 4 if I'm not going to move it, right? Yeah. Absolutely. Feel free. Okay. So now I'm going to take the antiderivative of both of these. But like we did with the previous problem, I'm going to use some u substitution. So what am I going to use for my u on the left side? 1 minus y. So what is my du? Negative 1 dy. Okay? So if I replace this, wait for it. Come back to me, pen. Did I finally lose my battery? Lord.
The same thing as
You never see what? All right, so we have u to the negative second power. But remember, I want this to be dy, and I'm going to write du, but du, is that equal to dy? No, it's equal to the opposite of dy. So when I put that du here, what has to go in front? The negative sign. Okay? So now I'm going to do add 1. What's negative 2 plus 1? Negative 1. Now I take the derivative in my brain. So if I take the derivative right now, I put the negative 1 in front. Then I subtract 1 from this power. What's negative 1 minus 1? Negative 2. And do I want that negative? I do. So actually, this is done. All right. I know. Exactly. So I'm going to write 1 minus y on the left side. Oops. Let's write it like this. I can. So I'm here. I'm right here. I'm adding 1 to get negative 1. So I was saying, okay, is this done? If I take the derivative of this, I should get that. Okay? So the derivative, I'm going to go ahead and move this to the front. Oh, there's my negative. And then I'm going to subtract 1, and I get that. So I don't need to put a negative in front of it to make it positive. You could, but then you'd still have to deal with the negative at the end. Okay? And I went ahead and wrote it as 1 over u, as opposed to u to the negative first power. Okay? Okay, let's do the right side. I'm going to put the 4 out front. Gross. Okay, let's do u substitution. What is our u? I'm sorry? I'm going to go back, don't worry. Exactly. Because both of them need it.
How do you know if they need it or not?
Try to do the antiderivative, and you're like, man, I don't know how to do it. Oh, hey, try to use substitution. What's the derivative of negative 2x? No, you're doing the antiderivative. Negative 2 du. Just taking the derivative. All right. Move this negative 2 to the other side to become negative 1/2 du. Ooh, I have too much here. Sorry. Equals dx. Okay, I'm going to try to plug it in for you. Ready? So this is u to the negative second power. All right, now watch this. I want to plug in dx here. Dx is the same as my du, right? My du. But what was in front of that du? So I need to move that to the front. What's already in the front? A 4. So those multiply together. What's negative 1/2 times 4? Negative 2. Okay. So now I'm going to do the antiderivative and do u to the negative first power. Let's take the derivative. All right, ready? So Alan, this is what that moment where if this is right, then when I take the derivative of this, I should get negative 2 u to the negative second power. That's what I'm checking right now. So move the negative 1 in front. So I got a negative 1 here. But what do I want? A negative 2. So I really need this to be in front is just a 2, right? Because negative 1 times 2 gives me negative 2. And then what do I do to that exponent? Subtract 1. Do I get negative 2? I do. So this is the same, right? This is my antiderivative. So I'm going to write it as 2 over 1 minus 2x. And then this side is the right-hand side. So what do I need to put on this side? Plus c. All right, let me pause here because we're definitely not done. But this is like a good stopping point to check. All right, so Bernadette, you can copy anything down that you're missing. Okay, so we just took the antiderivative of both sides. Now I'm going to solve for y, which would give me the general solution. Okay? That's the next step. Okay? Yes, go ahead.
For the d on the right side, you get negative 2 times d.
Got you. I took the derivative of this, which is 0. The derivative of negative 2x is negative 2 dx.
Okay. You just put the dx because it's like.
Yeah, because the variable is with respect to x. Good question. If,
4 times negative 2.
gotcha. So I want this dx by itself. So I move this over with division or multiplying by negative 1/2. So when I replace this dx, I need to do this whole thing. So I put the du there, and then I put this constant in front. What was already in front of 4? 4 times negative 1/2 gave me that negative 2. So that's how I got that.
How do you divide a positive number by a negative?
Okay. Now, are you asking for real?
Yeah.
How do I divide a positive number and get a negative?
Well, it's just like it doesn't make sense. Like I know how to do it, but like you have a positive number and then you divide it by a negative number, right?
Okay. And you're asking how does that give you a negative number?
Yeah.
Okay. I'm not going to answer that right now because we're doing this, but if you would like to talk about that, we can. All right. Now, do you guys see 1 over 1 minus y on the left side? I need that to not be in the denominator, right? So in order to do this, if I flip all of this, right, if I flip that, what do I have to do with all of this? Flip it as well. But watch, be careful when you do this. Ready? So this is 1 minus y equals 1 over 2 over 1 minus 2x plus c. I know, it's sick. Now we got fractions within fractions.
It's like inception.
Exactly. You've been listening. That's my joke that you should make.
You never watched Inception, bro?
It's all good, no worries. Do you see the one that's in front here? Do you see the one that's in front? Let's move it to the other side. Edwin's squinting, and it is like super large, and you're squinting, man.
I'm squinting because I'm like, what in the world? I'm crying inside.
I'm not
Okay.
even blind enough.
If you need tissues for that, I have them. Now, do I want it to be the opposite of y? No, I want just y. So watch what happens. This fraction now has a negative 1 on top. Notice I didn't touch anything in that denominator, okay? Okay, what did we just find? The general solution. Let's go. We're almost done. Now we got to use the initial condition to find the particular solution, which I already forgot, is y of 1 equals 2. Ah, so straightforward. Y of 1 equals 2. So I'm going to plug in, right? This is my x is 1, and my y is 2. Here we go. So 2 equals the opposite of 1 over 2 over 1 minus 2 times 1 plus c plus 1. X is 1. So I replace this with a 1. And then this value here is my y. I replace that with 2. Everything else is copied down.
So we can solve it?
Yeah, I'm going to solve for c. So that's, you can move this over. Right? If you move this over, subtraction, that gives you positive 1. Equals negative 1 over, I think we do this pretty easily. What's 1 minus 2? Negative 1. 2 over negative 1 is a negative 2. Right? And I already moved that 1 that was to the right side over. Now I'm doing algebra again. So it's going to be negative 2 plus c equals negative 1. So c equals 1. All that work for c equals 1. Let's write down our answer. Nice. I wouldn't do that, but nice. So negative 1 over 2 over 1 minus 2x. Plus
this
1.
The last one had trigonometry.
That's because it had e in there and trig. You thought that was harder. I actually don't think that's much. That ain't hard. This one had both u substitutions, right? I think that's harder. Triggers for nerds. Okay. Is that like supposed to be like a diss?
Yeah.